Hello everyone and welcome to another episode of Automation with ATmega 32 series of video tutorials. And like I said in the earlier video, today we are going to be looking at how to connect switches to our ATmega 32. And switches are actually input devices, and I can't really imagine a project without switches. Switches are mostly used to feed information to the microprocessor, microcontroller, or we can also get some information from the microcontroller using switches. So it's an interesting area. And sorry about that, excuse me. Now I'm just going to use the last project that we did on LED blink. If what you are looking at on your screen is actually what we did with our LED, and what I've done is actually to add a fourth set of switches or buttons. If you have watched the LED blink video, you actually it should not be challenging to add a component and connect it to the microcontroller, so I'll just skip that part. For the sake of those who are just joining, you're always going to, at the left part of your screen, we have a letter P. Just left click it, then type in push button in the search box. It's the first option that we have. Since we already have it, we are just going to skip this part and cancel. Adding it really straightforward, and connecting, you can connect to anywhere. At least that's how it's done. I'm not really going to connect anything because I've connected 4 buttons to each port. We have the first button or switch is connected to pin A0 for port A. The second one is connected to port B, pin B6. And the third one is connected to port C, pin C7. And the last one, we have it on port D, pin D4. So it's actually easy to see what we've done there. So that's it with the schematic part. Now let's turn to the firmware part. This is just what we did with our LED blink, and you can see the code is still intact. Now here we are just simply blinking an LED, switching it on and off. And now what we are going to do with this button is that we are going to control this LED using these buttons, but each button will control it differently. And excuse me, I'll show you that in a code when we are going to configure the code for doing that. So you've also noticed that I've added some lines of code, and these what I've done is introduce a function. By now, I'm sure you already familiarized yourself with the basics of C and C++, and there we always have functions and how to use functions in a code. And here, excuse me, sorry about that. Actually, what we have now is a button pressed function. That's the name of the function. Inside this function, we are going to pass 2 parameters. We have port pin, which is of data type character data type, and we also have port bit. And our function is returning a value of unsigned character data type. So we have a function that is returning a value, and at the same time we are going to pass 2 parameters inside that function. We'll see that when we'll be coding. And this function is actually going to help us debounce the switch. Just in a nutshell, let me say that it's important to note that buttons are actually mechanical devices that when you push, they bounce back and forth. And with every bounce, even if you pushed it once, it's going to bounce around back and forth. And with every bounce, every single bounce is actually going to be registered as a push to our microcontroller, and is going to be inconsistent. So we have to address it and actually do away with those bouncing. So you can do it in software, or you can also do it in hardware. So to demonstrate how a switch behaves when it's pushed, we are going to look at another software environment called Livewire. Livewire is another important a tool for this, and we are just going straight to creating a circuit. What I'll actually need, I'll need ground. You click it and then place it on our workspace. I'm going to need 2 grounds. I'm going to need a power supply. I'm also going to need an LED. I'm actually going to need a capacitor and a resistor. Those we find them in a passive devices, passive components, so to speak. I'm going to need an electrolytic capacitor. I'm also going to need an LED or a switch, push button switch, because we are demonstrating that when we push a switch, it's going to bounce back and forth, and that is undesirable for us. So we have our switch. We have our switch. Now we are going to add an LED. An LED is actually an output device. And we are done with the components. So let's just connect them. Connecting is very simple and straightforward in Livewire. Yes. So I think we are all students of science and physics, and all that I'm doing here is easy to understand. It should not be challenging, or even if it is, it won't sound as rocket science, because we're just doing basic circuit designing. I'm going to connect. Actually, I'm going to need another switch. Switches are input devices. At first, I'm going to simulate it without connecting the capacitor. Then actually, I'm going to let you know in a bit why we need capacitor. And this action is for hardware debouncing. Sorry about that. What else? We'll also need to have an oscilloscope. So we are going to add a measuring instrument, which is an oscilloscope. It's over here. And like I said, this is what we have at the end of the day. We have our oscilloscope. We have everything set up. Now to simulate, we are actually going to demonstrate that when a button is pushed, there is always going to be a bouncing, which is registered with the microcontroller. So simulate, let's just hit the run button. We're actually going to simulate it without simulating bouncing for now. Now if I push, watch out for switch 1, if I push it down, the LED will turn on. If I release, it's switched off. So you cannot see the bouncing at this point. Until now, to simulate bouncing, just come here to tools, then simulation, then check bounce. Now when I click this button over here, you can see the bouncing. And even if I'm not pushing the button, the LED is blinking. Let me just check. Now you can see all those blinks. Even though I'm not pushing the switch. Now we've scaled the time down to microseconds, so we can record many instances of spikes or bouncing of the switch. Even though I'm not pushing down the switch, we have all these spikes that are due to button bouncing. You can just increase this time to, okay. There we have it. So to debounce it, we can, like I said, we can do it in software or in hardware. In hardware, we can employ a capacitor. So I'll connect the capacitor so that when I push it, now you see, even though there are spikes, but they are actually tamed. So if I push it, our capacitor is doing the work for us. So actually, capacitor is charging and discharging at a faster rate. So it's going to filter out all those spikes, all those debouncing. So if I remove the capacitor and then push again, watch out for LED, and then watch out in our graph what happens. Then if I introduce the capacitor, so that's how a button behaves when it's pressed. Okay. And this is actually undesirable, because if you had a menu to select from with every button push, it will mean for the first push you are never going to select what you had in mind when pushing the button to select from the menu. So it's always going to scroll and scroll and scroll until this debouncing stops. So it's very important that we do a debounce either in hardware or in software. So this is hardware debouncing, which can always be addressed using a capacitor. Now let's turn to software debouncing using in our code. So okay, let's go back to Proteus. Now this function is going to do that for us. This is a function that I created to do software debouncing. So within the function we have two variables, count A and count B. Count A is equals to 0, count B is equal. So the pins that we have connected our buttons to are always kept as high at 5 volts. and then the other end of the button is connected to 0 volts. So when you push it, we are connecting the pin which was 5 volts to 0 volts. So at that instance, the bit is going to be cleared because it's going to be at 0 volts. I don't need that for now. So we are going to count the instances when it's on and the instances when it's clear. Remember, it's only clear when the button is pushed down. But because we are having debouncing, even though it's not pushed down, it's going to register bit is clear. So we are going to count all those bit is clear until it stabilizes. Now, when the bit is clear over here, when it's at 0 volt, that means the button is pushed down. Count A, which is less than count B, is going to increment. It's going to increment until it's equal to count B, which is more than. Now, that means at the instant when count A is actually equal to count B, at that instant, you can say at that instant that the debouncing have been all cleared and there are no more debouncing, and that's when it's going to return a value. So when count A, this is a do while loop that we are going to look into. Once again, if you have done the basics of C++ programming, you know how the do while loop works. So the moment, as long as count A is always going to be less than count B, this loop is going to happen again and again until variable A is equal to variable count B. So at the instant where count A is equal to count B, at that instant we can say that the debouncing is clear and there are no more debouncing. So at least that's how, at that instant where count A is equal to count B, the function is going to return 1. If it's not so, it's always going to return a 0. Hopefully you understood. Then we can move on to actually now we want to set up the pins that we have connected our buttons to. We are going to set up them up as input because switches and buttons are actually input components. So these pins are going to be set up as inputs. So to do that, the first input pin is pin A0. To do that, let me just run a pseudocode. Set button switches and button pins as input. Then, not just that, but we are also going to maintain them high and maintain button pins. We are going to maintain them as high, and then again I think that should be it. So our first switch is connected to pin A0, so we are going to make it an an input. This is how it's done. DDRB, data direction register on port A. It has to be an input. In A0. Shifter to the first pin A0. I'm just going to copy paste this one. Control C for copy. Then we'll modify it. Control V. So the second button is connected on port B. We've connected it on port B. Port B pin B6. Port B pin B6. Then the third one is connected on port C pin C7. Port C pin C7. Pin C7 on port C. Then the last one we have it on port D, pin D4. So this one, pin A0 of port A is configured as input. Similarly, pin B of pin B6 of port B is configured as input, and so on and so forth. Then we have to make them as we have to maintain them high. So once again, I'm just going to copy paste and do some tweaking. So this one is going to be actually this port A. Port B. Port C. And we have this one as lastly port D. To make them high, like we did with our LED blink. Yeah. This is how it's done. So setting up of pins and initialization are mostly done in our main loop or our main function, so that once the microcontroller is turned on, is powered on, code execution begins from the main function. So all this setup has to be done here before you actually go to while one loop, because once it's in while one loop, it never gets out of while one loop. So here in while one loop, what we're going to do is I can actually do away with this code, but so in while one loop, we are going to use different buttons to control our LED differently. So what I'm going to do is that the first button will blink our LED, twice. The second button, when it's pushed, it will blink our LED 4 times. The third will blink it 8 times, and the last one will blink it. The first will blink it twice. The second one will blink it 4 times. The third one will blink it 6 times, and then the fourth one will blink it 10 times. We can put it in. Now let's do. I'm going to comment the whole thing. I'm going to comment the whole thing out. So all this is commented out. Now when we are executing our code, the compiler is not going to see these lines of code. So this is how to comment lines of statements. More than one line of statements. With this one, just a single line is done, is commented out. But when we have this one, we've commented multiple lines. So what we are going to do now is to tell our microcontroller that when the first switch is pushed, the LED, our LED that we've connected to port B, pin B0, is going to blink twice. So we are going to use an if statement once again, the basic. Now we are going to call this function if button pressed. Copy, paste. If button pressed, we have unsigned car port pin, which is pin A0 actually. And then port bit. And this is pin A. Port bit should be 0.